Hello guys, it's me Teacher Hanji once again, and for this video, I'll teach you on how to solve quadratic inequalities. For our objective, identify quadratic inequalities. Next, express the interval notation correctly and solve and show the solution of quadratic inequalities through interval notation. Before we solve quadratic inequalities, let's try to review first how to rewrite the following quadratic inequalities into its standard form. Like what I've said in my lesson 9 video, this is the same with quadratic equation, only that this one uses inequality symbols. So let's try number 1. 3x squared minus 7x is less than or equal to negative 2. Okay, using addition property of equality, we have 3x squared minus 7x plus 2 is less than or equal to 0. Number 2, 2a squared is greater than negative a plus 3. Yes, using addition property of equality again, we have 2a squared plus a minus 3 is greater than 0. Let's have number 3. Quantity of f minus 1 times quantity of 2f minus 7 is less than or equal to 0. Yes, using FOIL method, we have 2f squared minus 9f plus 7 is less than or equal to 0. Number 4, 3y minus 2 is greater than negative 9y squared. Applying addition property of equality, we have 9y squared plus 3y minus 2 is greater than 0. Let us have the last one. 12b squared plus 5v is greater than or less than 3. Yes, applying addition property of equality again, we have 12b squared plus 5b minus 3 is greater than or equal to 0. Take note on how to rewrite those quadratic inequalities into standard form because we will do that as we solve quadratic inequalities. So now, let's solve the quadratic inequalities and express the solution sets using interval notation. Let's begin. Solve x squared plus 2x minus 8 is greater than or equal to 0. Let's remember the following steps in solving. First, turn inequality into an equation. Second, find solutions. And third, make a number line and check each solution and interval. So let us have this example. So instead of using less than or equal to symbol here, we will change it into equal sign. So we have the same x squared plus 2x minus 8 is equal to 0. Next, we will find the solution. So you have here three choices. Since it is a trinomial, we may use factoring, completing the square and quadratic formula. So for the example I'll present to you, I will be using factoring. So the factors of this equation is quantity of x plus 4 times quantity of x minus 2. So using the zero product property, which is x plus 4 should be equal to 0 and x minus 2 should also be equal to 0, then the values of x are negative 4 and positive 2. In our third step, we need to make a number line. So I have here a number line in which the points are negative 4 and positive 2. These are the points I obtained after finding the solution of this equation. So next, we will check each solution. So meaning, I'll be substituting negative 4 and positive 2 to our original quadratic inequalities. So using these inequalities, I'll replace or substitute negative 4 first to our inequality. So instead of using x here, I'll be using negative 4 now. So my inequality will be square of negative 4 plus 2 times negative 4 minus 8 is greater than or less than 0. Evaluating these inequalities, I have negative 4 times negative 4 is equal to 16. 2 times negative 4 is equal to negative 8. And negative 8 for the last one. And 16 minus 8 is equal to 8. And 8 minus 8 is equal to 0. Therefore, 0 is greater than or equal to 0. Or 0 is equal to 0, which means that this solution is true. Let us have our second solution. If x is equal to 2, the same, I'll be substituting this 2 to our x here or to our variables here. So we have 2 squared plus 2 times 2 minus 8 should be greater than or equal to 0. So let's try. After evaluating this one, we have 4 plus 4 minus 8. And 4 plus 4 is equal to 8. Minus 8 is equal to 0. Therefore, 0 is equal to 0. It means that our solution is also true. So take note of this. We will use closed circle if the boundaries are included. Otherwise, use open circle if it is not included. What do you mean by included? When you say included, meaning the solution set or the solution is true to our quadratic inequalities. So for our solution here, we found out that the solutions are true. So meaning I'll be using the closed circle. Next, we are not yet done because we need to find out the interval. So let us choose one point from negative 4 up to the negative infinity. We will choose any numbers that we want as long as it is in the negative 4 up to the negative infinity. We will also choose one point between negative 4 and positive 2. And last, we will choose another one point from positive 2 to negative infinity. It's up to you what number do you want to use. But for now, for negative 4 up to negative infinity, I'll be choosing negative 7. So if I use negative 7, I need to substitute that to our quadratic inequality. So we have square of negative 7 plus 2 times negative 7 minus 8 is greater than or less than 2, 0. Again, I use the same quadratic inequality. Now, if I evaluate that one, I'll obtain 49 minus 14 minus 8 is greater than or less than 2, 0. And 49 minus 14 minus 8 is equal to 27, which is greater than 0. Therefore, our solution is true. From negative 4 up to the negative infinity, meaning the solutions that are true. Let us have numbers between negative 4 and positive 2. So for now, I'll choose 0. Now I substitute 0 to our quadratic inequality. So we have 0 squared plus 2 times 0 minus 8 is greater than or equal to 0. If I were to evaluate that one, the answer will be 0 plus 0 minus 8 is greater than or equal to 0. Simplifying this one, we have negative 8 is greater than or equal to 0. So for now, negative 8 is less than 0. Therefore, this solution is false. We can't have numbers between negative 4 to positive 2. Let us choose numbers between 2 up to positive infinity. So for now, I'll choose positive 5. I'll be substituting that to our inequalities. We have 5 squared plus 2 times 5 minus 8 is greater than or equal to 0. Simplifying that, I have 25 plus 20 minus 8 is greater than or equal to 0. And this one is equal to 37. And 37 is greater than 0. Therefore, our solution is true. Now, let's see what is the interval notation. Take note that we will use bracket to indicate that the boundary is included. If not, we will use parentheses. So for now, since negative 4 and positive 2 is included, as well as negative 4 up to negative infinity and positive 2 up to positive infinity, therefore, our interval notation will be the union of negative infinity to negative 4 and positive 2 to infinity. Next, let us have another example. P squared plus 7p plus 10 is less than 0. Again, we need to turn it into an equation, find the solutions, and make a number lines and check each interval. Making that into an equation, we have p squared plus 7p plus 10 is equal to 0. Now, using factoring, the factors are quantity of p plus 5 times p plus 2 is equal to 0. Again, if you want to use quadratic formula or completing the square, you may do so, since we will arrive with the same solution. Applying zero product property here, I have p plus 5 is equal to 0 and p plus 2 is equal to 0, which means our p is equal to negative 5 and negative 2. Same as what we did in our first example, we need to make a number line in which the points are negative 5 and negative 2. The solutions that we obtain in step 2. Okay, now we will check if negative 5 and negative 2 are included or not. By substituting this point to our inequality, which is p squared plus p plus 10 is less than 0. Now, if p is equal to negative 5, then I have negative 5 squared plus 7 times negative 5 plus 10 is less than 0. Simplifying this one, I have 25 minus 35 plus 10. And 25 minus 35 is equal to negative 10 plus 10 is equal to 0. And 0 is not less than 0. It is equal to 0. Therefore, that one is not correct. So, let us again take note that if our boundaries is included, we will use closed circle. But if it's not included, we will use open circle. So, for our solution, is not included, therefore I'll be using a open circle. Next, how about if p is equal to negative 2? So again, we will substitute that to our inequality. So we have square of negative 2 plus 7 times negative 2 plus 10 is less than 0. Simplifying that one, the answer will be 4 minus 14 plus 10 is less than 0. And 4 minus 14 is equal to negative 10 plus 10 is equal to 0. Again, this 0 should be equal to 0 and not less than 0. For now, the solutions is also not included. So we will use open circle. Now, same as what we did in our first example, we will choose one point per each from negative 5 up to negative infinity. Points between negative 5 and negative 2, points between negative 2 and positive infinity. So for now, I'll be choosing negative 10. So let's substitute negative 10 to our inequalities. We have square of negative 10 plus 7 times negative 10 plus 10 is less than 0. Simplifying that one, we have 100 minus 70 plus 10 is less than 0. 100 minus 70 is equal to 30 plus 10 is equal to 40. Therefore, numbers between negative 5 up to negative infinity are not included. Next, let's choose one from this point. We have negative 3. Substituting negative 3, we have square of negative 3 plus 7 times negative 3 plus 10 is less than 0. Simplifying that one, we have 9 minus 21 plus 10 is less than 0. Last, we have negative 2 is less than 0. Now, it is true since negative 2 is really less than 0. Therefore, numbers or points between negative 5 and negative 2 are solutions or included. Next, I'll choose positive 1. Substituting positive 1 to our inequalities, we have 1 square plus 7 times 1 plus 10 is less than 0. Simplifying that one, we have 1 plus 7 plus 10 is less than 0, which is not true because 18 is greater than 0 and not less than 0. So meaning points from negative 2 up to positive infinity are not included. So to find our interval notation, again, we will use bracket if it is included and parentheses if it is not included. But for our inequalities, since negative 5 and negative 2 are also not included, we will be using parentheses alone. So this will be our set, negative 5 and negative 2. Okay, next example, example number 3. Solve quantity of x plus 4 times quantity of x minus 4 is greater than 0. So for this, we need to rewrite that into standard form. So meaning, we will be using FOIL method to rewrite that. I already used FOIL method, so my inequality will be x squared minus 16 is greater than 0. I need to change that into an equation, so I have x squared minus 16 is equal to 0. Through factoring, the solutions are quantity of x plus 4 times x minus 4. Applying zero product property, the value of x is negative 4 and positive 4. Now, let us make a number line in which the points are the solution. So we have negative 4 and positive 4. Let us check each solution. Let's see if that solution is included or not included. So let's start with negative 4. So for now, I'll be using this standard form. X squared minus 16 is greater than 0. It's up to you. If you want to use original inequality, you may do so. But for now, I'll be choosing the new standard form. We have square of negative 4 minus 16 should be greater than 0. And negative 4 times negative 4 is equal to positive 16. And 16 minus 16 is equal to 0. This one is false. Therefore, we will use an open circle to take negative 4 is not included. So let us have positive 4. 4 squared minus 16 is greater than 0. And 16 minus 16 is also equal to 0, which is not greater than 0. Therefore, I'll be using again open circle to indicate that positive 4 is not included. So let us try our intervals. So for negative 4 up to negative infinity, I'll be choosing negative 5. Points between negative 4 and positive 4, I'll be choosing 0. And points from positive 4 up to positive infinity, I'll be choosing positive 5. Again, you may choose any points that you want as long as it is between the given points here. So, using negative 5 as my value of x, I have square of negative 5 minus 16 should be greater than 0. And 25 minus 16 is equal to 9. And 9 is really greater than 0. Therefore, our solution is true. Therefore, the points between negative 4 up to negative infinity are included. So, let us try if x is equal to 0. So, I have 0 squared minus 16 is greater than 0. And 0 minus 16 is equal to negative 16, which is not greater than 0. Therefore, the points between negative 4 and positive 4 are not included. Let us have the last one. I have 5 squared minus 16 is greater than 0. So, we have 25 minus 16 is greater than 0. And 25 minus 16 is equal to positive 9, which is really greater than 0. So, meaning, the points between positive 4 up to positive infinity are included. So, our interval notation will be the union of set of negative infinity to negative 4 and positive 4 to positive infinity. So, for here, I'll use parentheses since negative 4 and positive 4 are not included. So, let us have our another example. 2m squared plus 2m is less than or equal to 12. So, rewrite that into standard form using addition property of equality. We have 2m squared plus 2m minus 12 is less than or equal to 0. Turn this inequality into equation. So, we have 2m squared plus 2m minus 12 is equal to 0. Find the solutions. I use again factoring. Again, you may do any methods that you want. So, I have quantity of 2 2m minus 4 times quantity of m plus 3. Applying zero product property, my m here is equal to 2 and negative 3. Now, I'll make a number line in which the points are negative 3 and positive 2, the solutions that I obtained in step 2. To check if these solutions are included or not, I will substitute it to our quadratic inequalities. So if our m is equal to negative 3, then I have 2 times square of negative 3 plus 2 times negative 3 minus 12 is less than or equal to 0. Again, I'll simply substitute the values of m that we obtained to our quadratic inequality. So, simplifying this one, I have 18 minus 6 minus 12 should be less than or equal to 0. And that is equal to 0, meaning it is true. Therefore, negative 3 is included. So, I'll be using closed circle here. So, let's write 2 here. So, if our m is equal to 2, we have 2 times 2 squared plus 2 times 2 minus 12 is less than or equal to 0. Simplifying this one, I have 8 plus 4 minus 12 should be less than or equal to 0. 8 plus 4 minus 12 is equal to 0, which is equal to 0 as well. Therefore, this solution is true and positive 2 is also included. That's why I use closed circle here. Now, let's just check their interval. Again, I'll be choosing points between negative 3 to negative infinity, negative 3 to 2, and 2 to positive infinity. So, for now, I'll be choosing negative 4, 0, and positive 3. Let's start with negative 4. So, substituting negative 4 to our quadratic inequality. So, we have 2 times square of negative 4 plus 2 times negative 4 minus 12 is less than or equal to 0. Simplifying this one, we have 32 minus 8 minus 12 is less than or equal to 0. And this one is equal to 12 is less than or equal to 0, which is not correct because 12 is greater than 0. So meaning points between negative 3 and negative infinity are not included. Now, let's check if 0 is included or not. So, if our m is equal to 0, substituting it to our quadratic inequality, so we have 2 times 0 squared plus 2 times 0 minus 12 is less than or equal to 0. Simplifying this one, we have 0 plus 0 minus 12 is less than or equal to 0. And 0 plus 0 minus 12 is equal to, yes, negative 12, which is less than 0. So, meaning this solution is true. So, the points between negative 3 to positive 2 are included. So, let us have our last point. If m is equal to positive 3. So, substituting this to our quadratic inequality, we have 2 times 3 squared plus 2 times 3 minus 12 will be less than or equal to 0. Simplifying that one, we obtain 18 plus 6 minus 12 is less than or equal to 0. And 18 plus 6 minus 12 is equal to 12, which is not less than or equal to 0. So meaning again, this solution is not included. So the points between positive 2 to positive infinity are not included. So to write the interval notation for that, we have set of negative 3 and 2. So I'll use bracket here to indicate that negative 3 and positive 2 are both included. So that's all for solving quadratic inequalities. So remember guys that in order to solve the interval notation of quadratic inequalities, the following steps should be followed. First, turn inequality into an equation. Second, find the solution of equation form as it will serve as the boundary points. And third, make a number lines and check each solution, then write it as interval notation. That's it for our video. You're doing a good job. Thank you for watching. See you again in my next video. Bye!